tools. And something I haven't said a lot about, but I want to emphasize is this world of the Respirosite, where you actually have something you can rely on, is not just about a better runtime environment, not about a better programming language. It's also tools for checking that guarantee or give you a very high confidence that what you've written is correct. Okay? And so, but you have to have the tools, you have to have the semantics that allow you to do that reasoning, and making large grain, allow you to reason to large grain makes it easier to write the tools and reason about it. Okay. Major architectural opportunities here. We need modules. We need to understand how versioning works. We need to know about building runtime environments that aren't one size fits all. We need to think about tailoring a runtime environment to a particular application or domain of applications. We have different instances of the Java environment, but it's still different code bases, different semantics. What we really need to think about is how we can extend a runtime environment. Yep, I'm all out of time. I just want to say, you'll have to ask me afterward about singularity. Just want to say about managed code at the bottom. There's another issue, which is how much of the system is built on top of managed code. And at some point, we have to believe that every single line of code in the system has to be written in type-safe language, or at least every single line that isn't checked by some kind of other mechanism. Because if it isn't, again, you have all the opportunities for failure. And Singularity is a project which is investing in this area. You can talk to me offline about it. We want to rebuild the operating system from the ground up in managed code. And that's my summary. Here we go. So I want to revisit Respirosites and say, if it's got C and C++ inside, are you going to put that in your body? so anyway, I hope I stirred up some thoughts at least. Thank you.
We have time for maybe one more question.
Yeah,
time for one more.
Yeah, sure.
Well, if no one else is going to, I'm just wondering about the startup time for your application, which makes me, given that it's something that we've been paying a lot of attention to with Parrot, and I just ran some benchmarks here, it seems to me that perhaps one of the things that we're not paying enough attention to doing VMs is properly mapping basically bytecode in our VM data to native OS structures. Because given your benchmark, it looks like you've got about 24 megabytes worth of code to load up, and you're spending a lot of time doing disk. I've got my work project on my laptop, and I don't have quite as much data, but I have 22 shared libraries. They're all bytecode, and then I load up the Postgres database library and the ncurses library within in Parrot, in my VM here, with a 1.6 megabyte bytecode executable. So it runs about, not counting the Postgres libraries, about 7 megabytes worth of data in the 22 shared libraries. I can load it up, get everything initialized to the point where it fails on database connection in 0.2 of a second. Which,
so is this the warm start behavior?
No, this is cold start behavior.
So you're getting 7 megabytes off the disk in 0.2 of a second?
So no, yes.
Okay.
Actually, I'm not getting 7 megabytes off the disk in 0.2 of a second. That's one of the places we win, and one of the things I'm thinking maybe we're not thinking about stuff enough. Because one of the things that we do is all our bytecode is designed to be M-mapped into the system. So all I need to load up is 3 megabytes of a Parrot executable. All my bytecode is M-mappable and directly executable.
Right.
So my startup time is much faster. I'm not here to brag. That's not the point. The point is maybe we're not thinking enough about what we're doing on startup and on mapping.
Yeah, actually, so is it the code and the metadata? Sort of the. So how much stuff that, well, we can talk about offline.
We can talk about it offline, but it's a lot.
Okay.
So
maybe in the interest of